Monday, ascent is initially traveling at 10 meter per second. We have given initial velocity. It accelerates uniformly. At a rate of 2 meter per second square for 4 seconds. How far does the car travel during this time? You have to write initial velocity, final velocity. You have to identify the quantities, knowns and unknowns. So Vf, A, delta x and t. Always if you will write this, you will be able to solve easily. Okay. So what is the initial velocity? That is 10 meter per second. What we have asked? Acceleration we have given 2 meter per second square. Time interval we have given 4 seconds. How far does the car travel during this? How far? That means it's asking delta x. So students, if you will see, this is the situation of no final velocity equation. So if you'll remember, no final velocity equation will be delta x equals VIT plus half AT square. Right? Now put the values, you will get the answer. No, 10 into 4 plus half into 2 into 4 square. So we got 40 plus 16, that means we got 56 meters. So this is the answer. I hope you understand this question and concepts. Let's take another example. A 2000 Ford Focus is traveling at a speed of 22 meter per second. The brakes can produce a maximum acceleration of 8 meter per second square. What is the minimum distance needed for the car to stop? So a car is moving with a speed of 22 meter per second and acceleration is applied of, we are applying the brake, so negative acceleration minus 8 meter per second square, right? And it's going to stop, let's assuming it's going to stop here, so its velocity will become 0. So here distance and displacement have the equal magnitude, right? So write the quantities. Vi we have 22 and finally it's going to stop. So final velocity will be 0 meter per second square, and Vi, Vf, delta x, A and T. We have asked about this. Acceleration we have given minus 8 meter per second square. So students, if you will see, we need to apply no time equation. So if you will remember, no time equation is Vf square equals Vi square plus 2a delta x. So delta x will be Vf square minus Vi square over 2a. We just need to put the values, we will get the answer. So students, what's Vf? Vf is 0, so 0 square minus 22 square over 2 into minus 8. From here we got 22 into 22 over 2 into 8. Let's simplify this. So we got 121 over, we will get what? 4 meters. This is our answer for this question. I hope you understand this question and concept behind it. We can go for another example. We can take another example. A jet requires 2.5 seconds of acceleration from rest to cover a 94-meter distance. What is the takeoff speed of the plane? And what was the acceleration? So students, we will have the same approach. We are going to write the terms or quantities Vi, Vf, A, delta x and T. A jet requires 2.5 seconds of acceleration from rest to cover distance 94 meters. So 94 is the delta x here. Time interval is 2.5 seconds. Starting from the rest is 0. First A is asked about what is the takeoff speed of the plane. So it's talking about final velocity, right? Don't go for the B. First solve A, then we will go for B. So we can think about for A, we need no acceleration equation. No acceleration equation. So if you remember, we can write delta x equals Vi plus Vf over 2 into T. So from here, can we write delta x? We have 94 and Vf, Vi is 0 over 2 into 2.5, right? We just need to simplify this. We will get the final velocity. So let's simplify this. We got Vf as 94 into 2 over 2.5. Now students, we can multiply numerator and denominator with 4. Benefit of that will be in the denominator we will get 10. 8 multiplied with 94 will be 32 and 75 and divided by 10 will be 75.2 meter per second. This will be the final velocity. So we got the answer for A, but we have also asked about acceleration. Then we know the final velocity. We can apply any equation. Let's apply Vf equals Vi plus At. So from here we will get acceleration Vf minus Vi over T. T is the 2.5. Vf we have 75.2. 75.2 minus 0 over 2.5. So we can write 75.2 multiplied by 4 over 10. So we got here 0.8 and 75 4 will be 300. Divided by 10, so we got 30.08 meter per second square. This is the answer for acceleration here. I hope you understand this question and concept behind it. Let's go to another example. An unusually athletic panda is initially running up at, how many questions we have to go? Okay, let's take one more example. An unusually athletic panda is initially running up at mountain with a speed of V when gets the inspiration to speed up with uniform acceleration for a period of t seconds. Afterwards, he is now running at a speed of 3V. So initial speed was V, and after t, initial speed was V. After t seconds, its speed becomes 3V. What distance did the panda cover during t seconds? Let's write the terms Vi, Vf, A, delta x and t. T is t, 3V and V. we have asked for first delta x. So students, what we do, we can apply vi plus vf over 2 into t, right? So 3v plus v over 2. Why we are doing this first question? Because I hope now you understand these questions and concepts easily. Now it's easy for you, right? So we got the delta x as 2vt. Second question is acceleration. We have to find out the acceleration. So students, in last question what we did, we can write vf minus vi over t. So 3v minus v over t. So 2v over t will be the 2v over t will be the acceleration. I hope you understand this question and concept behind it. Thank you. In the next part, we will learn about free fall. What is free fall? Like if we are going to drop this, so here initially we are dropping. When you are dropping, you see speed is 0. When it's coming down, it's getting accelerated, right? And its speed is continuously increasing. So we will learn this in next lesson. Thank you.